Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on surface area. So surface area is where we take the area of each of the faces of a 3D shape and add them up. In other words, it's the minimum amount of wrapping paper, the minimum area of wrapping paper you would need to wrap up a 3D shape. So let's start by looking at the figure that's on your screen, which is a rectangular prism. So a rectangular prism has 6 faces. So let's draw these inside so we can see. So each of its 6 faces is a rectangle, but they come in pairs. There's 3 pairs. So there's like the back and the front, for example. They are the same sized rectangle. And of course we have the 2 sides. They are the same rectangle, and also the top and the bottom, those 2 rectangles there. They are all the same rectangle. So we can come up with a formula for the surface area of a rectangular prism. If it has dimensions L, W, and H, L for length, W for width, and H for height, this will be TSA, the total surface area. So there's 2 lots of length and width. So in our example here, there's 2 rectangles, that are 12 by 8. And then there are 2 rectangles on the sides that are length times height. So 2 lots of 8 times 9. And then, of course, there's the front and the back. Both of those rectangles are 12 by 9. So this is how we'd figure out the surface area of this rectangular prism. So if I've done this right in my head, it's 552. Now the units are square units because we're talking surface area. Okay, but what makes surface area a little complicated is you have to consider whether the solid is closed or not. So this is the total surface area if the solid is closed. But what if it was open? What if I took away, say, the top rectangle here? Then the surface area would be different. So let's say I get rid of this top there. Well, if it was open, I'll just call that total surface area of open, it would be the same, 552, but we would have to subtract the top, which is 12 by 8. So we'd actually end up with 456 centimeters squared. So when you're finding the surface area of a prism of a 3D shape, it's very important that you make sure you know whether it is closed or open, because that will change the answer. All right, so that's for a rectangular prism. Let's now look at for a triangular prism. Please pause and copy this down if you need. So let's look at this triangular prism that's on your screen, and we'll try to find its surface area. Now, unlike for a rectangular prism, it's hard for us to come up with a formula. The reason is we do it slightly differently depending on the triangle that is the base of the prism. So for the one on your screen, the base of the prism is a right-angled scalene triangle. Let's look at a diagram of one that has an equilateral triangle as its base. So on your screen, I've put a prism whose base is an equilateral triangle. Now, what's similar about these 2 triangular prisms is they both have 5 faces, 2 triangles and 3 rectangles. The difference is, for the one that has an equilateral triangle as its base, all 3 of its rectangles are the same size. It turns out in the one up here, where its base is a right-angled triangle, all 3 of its rectangles are different. That's why we can't come up with a formula. So what we have to do is just use sort of brute force. We have to find the area of each triangle. They will always be the same. Both triangles in a prism will always have the same area. So we find the area of each triangle, then the area of each rectangle, and add them together. So in the example up here, the area of each triangle is 12 times 9, base times perpendicular height, divided by 2. That's the area of each triangle. And that's just 54, in this case, meters squared. Okay, so that's easy enough. So let's look at the 3 rectangles. So we have a rectangle here at the back. So that's 12 by 14. So the area of the rectangles, the first one is 12 by 14. If we look at the one at the bottom, this one here, that is 9 times 14. Now to find the third one, which is the one sort of at the top here, we need to find this length here, the hypotenuse of the right-angled triangle. So that can be done using Pythagoras. So it'll just be the square root of 12 squared, and it's plus. We're adding because we're finding the hypotenuse, and the answer is 15 meters. So the final rectangle will have an area of 15 times 14. And so that is 504 meters squared, if I've done that right in my head. So the total surface area is 504 plus 54, which is 558 meters squared. So whenever you're finding the surface area of a triangular prism, make sure you found the area of 2 triangles plus 3 rectangles. So once again, this is the area if it was closed. If it was open, like it didn't have one of the triangles, we would of course need to subtract that area from our total. So 558 was the area if it was closed. Now let's look at the total surface area now of a cylinder. So let's look at finding the surface area of this cylinder on your screen. So a cylinder is basically a prism, basically a circular prism. So I'm very sorry for my drawing. I'm absolutely horrible at drawing. So let's look at the net of this shape. Sometimes that's helpful when we want to find the surface area of a shape. We consider what it would look like if we squash it down to a 2D shape. So actually the net of a cylinder, we have 2 circles, but the curved surface is actually a rectangle. The rectangle that fits around the 2 circles. So if we have circle with radius r, it'll be the same for the top and the bottom of the cylinder. The area of those 2 circles together is 2 pi r squared. So what about the area of the rectangle? Well, this side here, the length of it is just the circumference of the circle because it has to fit around the circle. So the circumference of a circle is 2 pi times radius. And then this dimension here is whatever the height of the cylinder is. So the area of the rectangle is length, which is the circumference of the circle, times the height. So 2 pi r squared times 2 pi r h. So that's the total surface area of a cylinder. So once again, that's assuming it's closed. We'd need to make adjustments if it wasn't closed. So for the cylinder that I drew on the screen, again, sorry about the horrible drawing, its total surface area is 2 pi. Now, if the diameter is 10, the radius is 5, 2 pi r squared plus 2 pi times r times h. And you can put that straight on your calculator. So if I've done that right, I would get 569.90. This is to 2 decimal places, and again, it's units squared. So that's if it were closed. Let's say that this one was open and that I took away this circle at the top. I got rid of it. Well, then the total surface area, it only has one circle. So it would be not 2 pi r squared, but pi times r squared plus 2 pi r h. That part, the 2 pi r h, the rectangle wouldn't change. And this, of course, would change my answer. And now the answer would be, to 2 decimal places, 518.36. Obviously a little less. So this is the answer if it were closed. It had a circle at the top and the bottom. And this is if it were open, if the top circle wasn't there. Unfortunately, you have to make those adjustments with surface area. All right. Let's look at finding the surface area now of a composite shape, one that's a little more complicated. So let's look at finding the total surface area of this shape here. It's a rectangular prism plus half a cylinder. So if I look at finding the total surface area of the rectangular prism first, note that I only include the faces that are exposed. So the rectangular prism has 6 faces, but only 5 are exposed. So I only include those in my calculations. So if I look at, say, the front of it, this rectangle here, there's one just like it at the back. Both of them are 42 by 35. And then, of course, the two sides of the prism. If I'm looking at this one here, that's 35 by 9, and there are, again, two of them. But the bottom of the rectangular prism, which is this face here, 42 by 9, there's only one of them. Because the top is not exposed, I don't include it. So putting that on my calculator, I get 3,948 centimeters squared. So now I must find the total surface area of the half cylinder. So just put a circle there because it's kind of like a circular prism. Remember, the total surface area of a cylinder is 2 pi r squared plus 2 pi rh. So in this case, if we look at the cylinder, its diameter is 9, so the radius I'm going to replace with 4.5, half the diameter. And of course, the height of the cylinder is 42. But this is only a half cylinder, so I need to divide by 2. Now, normally when you have a half cylinder, you need to include the rectangle that's on the bottom of it. But of course, this rectangle here at the top is not exposed again, so I won't include it. So I'll just leave the total surface area of the half cylinder as this, and you put it on your calculator, you should get to about 2 decimal places, 657.38 centimeters squared. So of course, that means that the total surface area of the whole prism is 3,948 plus this approximate value, which of course gives you 4,605.38 centimeters squared. How easy is that? So I want to do just one more example, this time where we're using the surface area to find an unknown side. So again, please pause and copy this down if you need. So here we have a closed rectangular prism with a square base, the area of the square base 64 centimeters squared, and we are told that the total surface area of the shape is 608 centimeters squared, and we're going to find the volume of this rectangular prism. So firstly, we know it's closed. That means all 6 faces of the rectangular prism are there and count towards the surface area. Now, to find the volume, we need all 3 dimensions, the length, the width, and the height. So whenever you're finding an unknown side, whether it's area, surface area, or volume, you set up an equation using the formula. You substitute in everything you do know and rearrange to find what you don't know. So we know that the total surface area of any rectangular prism is 2 times length times width plus 2 width times height plus 2 times length times height. Okay, that's for any rectangular prism. We're told the total surface area is 608 centimeters squared. Now, if the square base has an area of 64 centimeters, obviously that means that 2 of the dimensions are equal to 8. It doesn't matter which dimension you call length, width, or height. So let's just say, for argument's sake, that the length equals the width is equal to 8. So I have 2 times length is 8, width is 8, plus 2 times width is 8 times height, plus 2 times length is 8 times the height. I am trying to find what h is. Let's tidy this up a bit. So I've got 608, 2 times 8 times 8 is 128, plus 16 times the height plus 16 times the height. I now have an equation that I can solve. So 608 minus 128 gives you 480, and of course 16h plus 16h is 32h. You know how to solve these. Divide each side by 32, you get 15 is the height. So we've set up an equation, substituted what we do know to find the unknown dimension, the height. We now know that that is 15. So if this rectangular prism has a square base that's 64 centimeters squared, and its total surface area is 608 centimeters squared, its dimensions are 8, 8 and 15, so the volume is just 8 times 8 times 15, which is 64 times 15, 960 centimeters cubed. Okay, how easy is that? I'll just reiterate, whenever you're trying to find an unknown dimension, like a side, in area, surface area, or volume, set up an equation with the formula, substitute everything you do know, and rearrange to find what you don't know. All right, sorry for another long video. Hope you found it informative. This has been the luckiest maths teacher in the world. Have a great day.